Hello, Teacher Ara here. Welcome to my class. Our topic for today is all about waves. So now, are you ready to learn? Let's get started. Before we proceed with our discussion, let us first identify our learning targets. So at the end of the lesson, you should be able to define wave in the context of physics. Second, identify the different types of waves. And third, solve for the different properties of waves. So my dear students, kindly make sure that you have your pen or pencil and notebook or any kind of paper where you can write essential notes during our discussion, because we will use them in order for you to solve for the sample problem that we will have later on. So we have three topics under waves, which are nature of waves, types of waves, and periodic waves. We'll be focusing first with the nature of waves, so let us now proceed. Okay, here is the definition of a wave. A wave is a disturbance that propagates through a medium. There are three words in that definition that may need to unpacking. First is the disturbance, second is propagate, and third is medium. Okay, let us first define disturbance. Okay, a disturbance is a change from the current state of a measurable quantity at some location. And a disturbance have examples, which are change in kinematic variable like position, velocity, or acceleration. Second is change in intensive property like pressure, density, or temperature. And last is field strength, that can be in the form of electric field, magnetic field, or gravitational field. Okay, second term is propagate. To propagate is to transmit the influence of something in a particular direction. So for a wave or waves to travel, it needs to propagate or be transmitted from one location to another. A wave can propagate through a medium, which is the third term or word that we need to define from the definition of wave. So a medium is defined as the substance through which a wave can propagate. Take note that a medium is not the wave itself. Okay, it's not the wave, because it is only a substance or a material that carries the wave for it to travel from one location to another. The first example that comes to mind when most people hear the word wave are the kinds of waves that one sees on the surface of a body of water, like deep water waves in the ocean or ripples in a puddle. Relatively, waves can also be observed in a swimming pool. So, as you can see in the picture, the swimming pool is calm since the surface is flat and smooth. And if you drop a rock into it, the surface will be disturbed, right? The area of disturbance will be higher than normal in some places and lower than normal in others. The disturbed water at the point of impact disturbs the water next to it and will form what we call ripples. The disturbance spreads outward, transmits, or propagates. The medium through which this disturbance propagates is the surface of the water. So see, there are various instances where you can already observe the occurrence of wave, like in water or in a material that can carry a wave, like a string or a rope, and many more. Okay, let us now proceed with our second topic, which is the types of waves. So there are two main types of waves, which are electromagnetic waves and mechanical waves. But first, let us define electromagnetic waves. So, an electromagnetic wave is a wave that is capable of transmitting its energy through a vacuum. This is an empty space, so it doesn't need any medium that will carry the wave, because electromagnetic wave can already transmit from one location to another without any carrier. Electromagnetic waves are produced by the vibration of charged particles. An example of electromagnetic waves are the waves produced by the sun that subsequently travel to Earth through a vacuum or outer space. The ability of electromagnetic waves to travel through a vacuum is one of the factors that life on Earth is possible. So basically, all light waves are example of electromagnetic waves. So there are many forms of electromagnetic waves which are indicated in the basic electromagnetic spectrum, arranged based on the increasing wave frequency, which are radio waves, microwaves, infrared, visible light, which is the light that we can see in our naked eye, followed by ultraviolet rays, X-rays, and gamma rays. So again, electromagnetic waves can propagate through transparent materials and can also propagate through empty space or a vacuum. Okay, now let us proceed with the second type of wave, which is mechanical wave. A mechanical wave is a wave that is not capable of transmitting its energy through a vacuum. Take note, it's not capable of transmitting its energy, unlike with electromagnetic wave, right? So mechanical waves require a medium in order to transport their energy from one location to another. So sound waves is the most important example of a mechanical wave. Sound waves cannot travel through a vacuum, so it is one of the good example of a mechanical wave. Okay, there are two types of mechanical waves, which are transverse wave and longitudinal wave. Okay, transverse wave is a wave in which particles of the medium move in a direction perpendicular to this direction the waves move, while a longitudinal wave is a wave in which particles of the medium move in a direction parallel to the direction that the wave moves. Okay, my dear students, for you to have an idea about transverse wave and longitudinal wave, here is a short video that you can watch for you to visualize what is really happening in transverse wave and longitudinal wave. So here it is.
In this video, we're going to look at two ways they can be classified. Waves are produced as a result of vibrations and can be classified as transverse or longitudinal. Whether they are transverse or longitudinal depends upon how the particles are made to vibrate as the energy passes. Let's look at longitudinal first. This is where the particles vibrate parallel to the direction in which the wave of energy is travelling. Notice that the ends of the slinky don't ever leave the hands holding them. It's only the energy that travels. The places where the coils or particles are bunched together are called compressions. Where they are furthest apart are called rarefactions. An example of longitudinal waves is sound. When a drum is struck, the drum skin vibrates, which causes the air particles next to it to vibrate. This causes the next air particle to vibrate, then the next, and so on until the vibration reaches the ear, causing the eardrum to vibrate. The vibrating air speeds away from the source, creating a sound wave. Let's look at another type of wave, transverse waves. The hand moves up and down, as does the slinky, but the wave itself moves from left to right, so the particles vibrate at 90 degrees to the direction that the energy is moving. We can simply think of it as, in longitudinal waves, the hand pulses horizontally, pushing and pulling, and the wave energy also moves horizontally, back and forward. Whereas in transverse waves, the hand moves up and down, but the wave energy still moves horizontally. Again, the ends of the slinky never leave the hands holding it, it's just the energy that moves along. Now you should be able to describe the differences between transverse waves and longitudinal waves. Remember, it is the energy and not the slinky itself that travels.
Now that you have watched the short clip, let us now proceed to our third and last topic, which is periodic waves. Okay, a periodic wave develops when the free end of a medium like a rope or a string applied with a repetitive or periodic motion, then each particle in the medium also undergoes periodic motion as the wave propagates. If you are wondering about periodic waves, it is similar with the transverse or longitudinal wave that you watched a while ago. So they are basically types of periodic waves. So now we will be focusing with the characteristics of periodic waves. Okay, we will first discuss periodic wave in a form of transverse waves. The transverse wave on a stretched rope in the GIF image is an example of a wave pulse. So the hand shakes the string up and down just once, exerting a transverse force on it. The result is a single wiggle or pulse that travels along the length of the rope. Consequently, each particle in the rope will also undergo periodic motion as the wave propagates, which results to a periodic wave. The tension in the string restores its straight line shape once the pulse has passed. Next is, when a wave undergo a periodic motion, it will have periodic wave properties, which are the amplitude, frequency, period, and angular frequency. And the wave that is produced is a sequence of crests and troughs. If you are wondering what is the definition of amplitude, amplitude is basically the maximum displacement of a wave from its equilibrium position or the rest position. And for frequency, it is the number of cycles of the motion of a wave per second. And the period is the time required for a wave to complete one cycle of motion. And of course, angular frequency refers to the angular displacement per unit time or the rate of change of the phase of a sinusoidal wave form. So don't be confused with angular frequency and frequency itself, because they are basically different in terms of property, because frequency refers to the number of cycles of the motion of a wave per second, while the angular frequency refers to the change of the phase of a sinusoidal wave form. Okay, let us discuss these properties later on as we go on with our discussion. So let me first introduce to you the equations for frequency, which is represented by the lowercase f, which is equals to 1 over t, or the period, which is represented by the uppercase T. And for period, it is equals to 1 over frequency or f. And of course, for angular frequency, it is represented with the symbol omega, which is equals to 2 pi f. Okay, let us now discuss further the properties of a periodic wave. So, periodic waves with simple harmonic motion are particularly easy to analyze, right? We call them sinusoidal waves. It also turns out that any periodic wave can be represented as a combination of sinusoidal waves. As you can see in the GIF image, it is basically a sinusoidal waves. So don't be confused with the terms because there are just another terms for periodic waves, for simple harmonic motion, and they are basically manifesting the same type of motion, which is up and down, or from left to right, or right to left. Okay, here are the parts of a transverse wave. First is the crest, and also the trough, which was mentioned a while ago, and also the wavelength, and the amplitude. So, as you can see in the image, the crest is located at the upper or top part of the wave, and the trough is the bottom part of the wave from the equilibrium position or the natural position of the wave. And also, you can see the wavelength. So, the wavelength is the distance from one crest to the next, or from one trough to the next, or from any point to the corresponding point on the next repetition of the wave shape. And the amplitude is defined as the maximum amount of displacement of a particle on the medium from its rest position. So, in a sense, the amplitude is the distance from rest to crest. Similarly, the amplitude can be measured from the rest position to the trough position. So, kindly take note of the essential information about the parts of a transverse wave because you can use that later on. So, I repeat, the crest is at the top part of the wave and the trough is at the bottom part. And the wavelength is the distance between two consecutive crests or two consecutive troughs. And the amplitude is the maximum displacement of the wave from its equilibrium position or rest position. Okay, and here are other equations for the wave properties, which are wave speed, frequency, and wavelength. So the triangle there will help you easily remember the equations to be used for frequency, wave speed, and wavelength. So you can use them during your problem-solving activities in your physics classes. So okay, so the fundamental equation for waves is the wave speed, which is equals to frequency times wavelength. So wave speed has a unit of meters per second, and frequency has a standard unit of Hz or hertz, and for wavelength it has a unit of meter. Okay, you can easily manipulate properties there to compute for wavelength and the frequency. So you can easily compute for wavelength, which is equals to wave speed over frequency. And for frequency, it is a wave speed over wavelength. After the transverse wave, let us now proceed with the longitudinal wave as a form of periodic wave. The simple harmonic motion of a particle in a longitudinal wave is parallel to the direction of the wave propagation. As you can see in the GIF image, the particles within a medium will just follow the direction of the wave or the propagating wave that is occurring. And here are the parts of a longitudinal wave. So, like in the transverse wave, the longitudinal wave also have amplitude, which is again the maximum amount of displacement of a particle on the medium from its rest position. And also, we have compression and rarefaction. In the transverse wave, we have crests and troughs, right? But here in longitudinal wave, we have compression and rarefaction. As you can see in the image, the compression is the part where the waves are closer to each other. And for rarefaction, it is the part where the waves are more distant from each other. And we have also the wavelength, which is the distance from one compression to the next or from one rarefaction to the next. So the fundamental equation for wave speed is also applicable for longitudinal waves, since it is considered as a form of periodic wave, which is V is equals to lambda times F, or wave speed equals to wavelength times frequency. Okay, I hope that you were able to take note for the essential notes for our discussion today. Let us now have a practice problem. So for you guys to be able to apply the concepts of our lesson for today, I have here a sample problem for you. So let me first read to you the said problem. Extreme waves along ocean waters, sometimes referred to as freak waves or rogue waves, are a focus of much research and study among scientists. Several merchant ships report rogue waves, which are estimated to be 25 meters high and 26 meters long. Assuming that these waves travel at speeds of 6.5 meters per second, determine the frequency and the period of these waves. Okay, my dear students, let us now begin solving our sample problem. Let us begin with identifying our given. Okay, given. Please bear with the writings because I'm just writing in a digital pad, as you can see. So, based from the problem, the waves are 25 meter high, meaning it is our amplitude. Okay, amplitude. Since amplitude is the maximum displacement of a wave from its rest position or equilibrium position. Okay, the second given in our problem is the wave is 26 meters long, meaning it is our what? You're correct. It is our wavelength. So, wavelength is also defined as the distance between two consecutive troughs and two consecutive crests. And the last given on our problem is 6.5 meters per second, meaning it will be our wave speed. Okay, 6.5 meters per second. Okay, now that we have already identified our givens, let us now proceed with our solution. Since we have to determine for frequency and period, let us use the equation for frequency and period identified on our discussion. If you can recall, frequency is equals to wave speed over lambda, and for period it is equals to 1 over frequency. So now that we have identified as well our equations, let us now substitute the values. Okay, let us first have the frequency. So the wave speed is 6.5 meters per second, and the wavelength is 26 meters long. Okay, if you calculated these values using a calculator or through your mental calculation, we can get 0.25 hertz, which is the standard unit for frequency. Okay, and let us now get the period, since we already know the value for frequency. So it is 1 over 0.25 hertz. Okay, now if you type it on a calculator, you will get 4.0 seconds, which is the standard unit for period. Okay, so we have the final answer. Final answer. Okay, for frequency we have 0.25 hertz, and for period we have 4.0 seconds. Okay, I hope that you have learned something today, and I was able to help you with your studies in physics, specifically in terms of waves. And if you wish to practice more on solving of properties of waves, you can always comment down below, and I will send you the link that contains the different practice problems that you can always solve, so that you can have higher scores on your physics classes. Okay, good luck on your studies, and God bless. I hope that you are always in a good condition, and stay safe. Always have a positive attitude in learning, because learning is fun. Okay, bye.